A new Chinese aircraft, the J-36, was spotted during test flights over Chengdu, Sichuan on December 26, 2024. Its unusual, almost alien design immediately raised questions. Was this a UFO, or had China developed a true sixth-generation fighter to challenge the United States? The J-36 seems to reflect more than a decade of work, and not all of it appears to be Chinese. Much of its design echoes decades of American development. So, was it truly developed by China, or was it just stolen from the U.S.? A leaked 2012 document reportedly shared at Beijing's 2009 Next Gen Fighter Symposium suggested that specifications for a sixth-generation aircraft were discussed many years ago. However, it was in 2019 that the chief designer at the state-owned Chengdu Aircraft Corporation announced that the development of the J-36 had begun with pre-research with an operational sixth-generation fighter target by 2035. In the video that unveiled the J-36 wasn't flying alone. Another Western nightmare was flying right next to it. Smaller, similar-looking aircraft now widely known as the J-50. Their flight arrangement appears to imply that the J-50 is a royal wingman to the J-36, America's new fighter, being developed under the Next Generation Air Dominance Program, or the NGAD program, is widely known to also be designed to have loyal wingman escorts. China's J-36 will have advanced stealth, AI-assisted systems, and hypersonic missile capability to position itself as a versatile platform for penetrating contested airspace and executing multi-role missions. All of these are also expected of America's NGAD fighter. Could this be a case of two formidable militaries building a similar aircraft? Or could something more sinister be at play? Espionage, for instance, just like China did with the American F-35 to build the Chinese J-35, U.S. officials, including former Defense Acquisitions Chief Frank Kendall, have claimed that stolen F-35 data compromised through cyber attacks in 2007 accelerated China's fifth-generation fighter programs, including the J-35. Documents leaked by the most popular and most consequential whistleblower is almost all of history. Edward Snowden, in 2015, published by Der Spiegel, confirmed the theft of over 50 terabytes of F-35 data, including radar, engine schematics, and stealth technologies like heat reduction methods. In 2014, Su Bin, a Chinese national, was indicted for stealing data for both the F-22 and F-35 to be relayed back to China. While no direct evidence links the J-36's design to stolen technology, the precedent set during the development of its fifth-generation fighter jets does raise suspicions. However, the J-36's unique tri-jet and double delta wing configuration indicate indigenous innovation, possibly building on lessons from the J-20 and J-35. Critics argue that while espionage may expedite development, replicating complex systems like the F-35 sensor fusion or coatings is improbable without comparable industrial capabilities. Therefore, to some degree, China's aircraft building capacity is impressive, and it gets even more impressive when we see the capabilities of the new J-36 sixth-generation fighter. The J-36 is a tailless, tri-jet, diamond double delta-winged aircraft developed by the Chengdu Aircraft Corporation, designed for stealth, air superiority, strike missions, and command and control of aircraft teaming operations. The J-36 aims to challenge U.S. air dominance in virtually every type of mission by wielding the most cutting-edge technologies the Chinese military complex can conjure up. Cutting-edge technologies such as advanced stealth capabilities. The J-36 has a tailless, flying wing configuration somewhat similar to that of the B-2 Spirit bomber and many sixth-generation aircraft concepts flying around. This signifies a major focus on a stealth-oriented design, minimizing radar cross-sections across multiple frequency bands, including X-band and low-frequency radars. The lower the radar cross-section, or RCS, the more difficult the aircraft is to spot by enemy air defense systems. This is why the B-2 Spirit can fly into enemy airspace unbothered, like it was only going on a cruise. The smooth, blended J-36 airframe incorporates radar-absorbent materials and coatings, likely derived from advancements in the fifth-generation fighters J-20 and J-35 programs. The J-36 diamond-shaped double delta wing and an estimated wingspan of 62 feet and a length of 75 feet optimizes aerodynamic performance and allows for transonic and supersonic flight while maintaining this low profile. The tri-jet engine configuration, featuring two underwing intakes and a dorsal intake behind the cockpit, is a very unique feature, enhancing stealth by burying engines deep within the airframe to reduce infrared signatures. The dorsal intake will likely be supporting a high-thrust engine. Analysts suggest the J-36 employs advanced thermal management systems, potentially inspired by U.S. designs like the F-35's heat reduction methods, to keep the heat from these engines hidden from the outside world. This will further minimize infrared detectability and ultimately improve stealth. Propulsion and performance. The J-36 is likely powered by three WS-15 or WS-19 turbofan engines, with thrust vectoring capabilities to compensate for the tailless design's inherent instability. The WS-15, developed for the J-20, delivers approximately 180 kilonewton of thrust per engine, while the WS-19, a newer variant, may offer improved fuel efficiency and power. The total power output of these engines sits at about 420 kilonewtons. The tri-jet setup provides redundancy, allowing the aircraft to sustain operations if one or even two engines are damaged, a critical feature for long-range missions in contested environments. The dorsal engine likely supports supercruise, enabling sustained supersonic flight without afterburners, a critical capability for penetrating contested airspace. The underwinged engines could be optimized for fuel efficiency to allow extended loiter times. To dominate today's numbers, the J-36's performance likely includes a maximum speed of around Mach 2.5, a service ceiling above 60,000 feet, and a combat radius exceeding 1,000 mules based on comparison with the J-20 and NGAD concepts. The thrust vectoring capabilities enhance maneuverability, enabling high angle of attack maneuvers despite the tailless design's limitation. An aerodynamic profile with a low drag coefficient, high altitude, long-range operations, and blurry speeds in one airframe. The J-36 is the ultimate recipe for both air superiority and deep strike missions in the Indo-Pacific theater. Avionics and sensor suite. The J-36 must be more than just a well-thought-out lump of composite materials and wires with a comfortable seat in front for a pilot to make virtually all the decisions. If the fighter will dominate the skies of today and tomorrow, it must be sensitive and super intelligent, almost alive. For this reason, the J-36's avionics suite is a cornerstone of its sixth-generation classification, integrating AI, sensor fusion, and networked warfare capabilities. The aircraft likely features an active electronically scanned array radar with conformal antennas embedded in the airframe, providing 360-degree situational awareness. These radars, possibly an evolution of the J-20's Type 1475, offer long-range target detection and tracking, capable of engaging multiple targets simultaneously. Electro-optical infrared systems similar to the F-35's EOTS would provide passive detection and targeting, reducing reliance on radar emissions and maintain stealth. AI-driven systems are a defining feature, enabling autonomous decision-making, threat prioritization, and coordination with unmanned wingmen. As said earlier, the J-36 is designed to command loyal wingman drones, such as the GJ-11 stealth drone, in a manned-unmanned teaming configuration. This capability allows the J-36 to delegate tasks like reconnaissance or electronic warfare to drones, enhancing mission flexibility. The aircraft's side-by-side cockpit, observed in prototypes, suggests a two-seat variant for managing complex missions, with one pilot focused on flight and the other on systems coordination. The The J-36 will have an electronic warfare suite that likely includes advanced jammers and direction energy countermeasures to disrupt enemy radar and missile guidance. Data links, possibly based on China's Beidou satellite system, enable real-time integration with assets of the Chinese Air Force, Chinese Navy, and allies, creating a constantly networked kill web. This connectivity ensures the J-36 can share targeting data with crucial platforms like the H-20 bomber or Type 055 destroyers on the go, keeping every member of the Chinese force abreast of the battlefield situation at all times. Weapons and payload. One benefit of the J-36's large structure is its ability to carry a lot at once, including weapons. Within the aircraft's massive internal weapons bay, estimated to hold 8 to 10 tons of ordnance, could be a diverse lethal payload, including air-to-air, air-to-ground, and hypersonic munitions. By housing its ordnance in these internal bays, the J-36 can maintain its stealth profile even while armed to the teeth. Compare this to fourth-generation fighters, which usually carry their ordnance or external hardpoints, and it's easy to see how the J-36 configuration has much fewer points for radar waves to bounce off from during enemy attempts to detect the fighters. The J-36 could also carry ordnance on external hardpoints when stealth isn't of topmost priority. This would increase the J-36's payload capacity to about 12 tons. Primary air-to-air weapons in China include the PL-15 and PL-17 missiles with ranges of 120 to 190 miles. For strike missions, the J-36 could deploy precision-guided bombs like the YJ-83K or hypersonic cruise missiles, such as the DF-ZF glide vehicle. The vehicle's compatibility with hypersonic weapons is a game-changer, enabling rapid strikes against high-value targets like aircraft carriers or command centers. There have been talks of the J-36 wielding laser weapons. While speculative, this is in line with sixth-generation fighter trends. It also would be a game-changer. In summary, the J-36 will be a versatile expert in weaponry, a machine capable of destroying fellow aircraft, ground bases, carriers, and so much more, using literal tons of weapons at its disposal. The J-36 could easily be the U.S.'s greatest challenge in the skies in a conflict with China. The U.S. military knows this too. A secret aircraft factory somewhere in the U.S., the NGAD fighter is taking shape, preparing to counter the Chinese aircraft pound for pound, intelligence for intelligence, missile for missile. This aircraft will be America's response to the J-36, and it now has a designation, the F-47. The F-47, developed by Boeing under the NGAD program, is a sixth-generation fighter designed to counter advanced threats like China's J-36, announced on March 21, 2025 by President Donald Trump. The F-47 is a stealthy, long-range, manned-unmanned teaming platform intended to replace the F-22 Raptor, current most lethal fighter in the skies today, and the world's original fifth-generation fighter. With a combat radius exceeding 1,150 miles, speeds above Mach 2, and a slew of other advanced technologies, the F-47 is tailored to neutralize the J-36's capabilities in stealth, range, and networked warfare, ensuring U.S. air superiority in contested environments like the Indo-Pacific stays right as it is or grows even more superior. The J-36's tailless tri-jet diamond double delta design prioritizes stealth and range. With a large airframe and 3 engines delivering hundreds of kilonewton of thrust, its low radar cross-section and internal weapons bay enable it to penetrate defenses and carry hypersonic missiles or PL-17 air-to-air missiles for long-range strikes. The F-47 counters these with what can be referred to as stealth plus technology, starting with a flying wing design, radar absorbent material coatings, and much more that combine to surpass the already impressive low observability of the F-22 and F-35. The F-47's adaptive electromagnetic signature management dynamically counters multiband radars, including China's low-frequency systems, while advanced thermal management reduces infrared signatures, mitigating the J-36's detection capabilities. The F-47 is reportedly equipped with 2 XA-100 and 101 adaptive cycle engines, each producing 200 kilonewtons for a combined 400 kilonewtons of thrust. These engines enable super cruise, fuel efficiency, and combat radius 70% greater than the F-22's 680 miles, allowing the F-47 to operate deeper in contested airspace without heavy tanker reliance. The F-47 sensor suite and AI-driven avionics likely outmatch the J-36's capabilities thanks to decades of head start in developing such technologies for the U.S. The F-47 will be armed to the teeth in its internal weapons bay, which will feature the most lethal weapons the U.S. Air Force has in its arsenal, such as the AIM-260 Joint Advanced Tactical Missile, laser-based weapons, and hypersonic missiles. Furthermore, the F-47 is designed to be more advanced than it is as time goes by. This means the fighter has an open architecture that ensures rapid upgrades to counter evolving threats. With 185-plus units planned for delivery by 2029, the F-47's production scale and technological edge position it as the ultimate response to China's J-36, one that promises to secure U.S. dominance in future air conflict. In a few years, the most technologically advanced fighter jet in the world would likely be one of the main fighters discussed today. The second fighter will be its greatest nemesis, trying to steal the crown. This is a battle that could last decades, and the only way to truly know which will win is by giving this video a like and subscribing to this channel. So do that now, and thanks for watching.